Here we are going to talk about trigonometric substitutions, the examples from homework. As you will see here, we have these transformations.
Yeah.
So we are gonna have either three types of transformations: x is equal to a tangent, x is equal to a sine, x is equal to a secant theta. By doing these transformations, we will be able to simplify the integration that we are given. For example, let me tell you a couple more examples here. In this one, so how do we know that we are going to use x is equal to 2 tangent theta? Because this is in the form of, look, when I go back to here, so we have, look, square root of a squared plus x squared is equal to a times absolute value of secant theta. So it is, if you see in the integration square root of a squared plus x squared, then you are going to use x is equal to a tangent theta. If you see square root of a squared minus x squared, then you are going to use x is equal to a sine theta transformation. If you see in the integration square root of x squared minus a squared, you are going to use x is equal to a secant theta as the substitution. This is the trigonometric substitution that we have some questions here in the test. So in this case, we have square root of a squared plus x squared. So in this case, we are going to use x is equal to a tangent. But what is a? A is just a 2 tangent theta, and then the integral is going to be much simpler if you do this trigonometric substitution, as you will see here. So the integral is just integral secant theta at the end, and we know that the antiderivative is ln absolute value of secant theta plus tangent theta. There's another example. So this is similar. Again, we are going to use the let me see just a sec. This is the we don't want to use hyperbolic. Let me see, because I don't want you to learn about that. I told you about that. And then here, let me see the answer, because this is, I think, arc sine. Yeah, arc sine, so that's fine. Arc sine you already know. So in this example, for example, you would use x squared dx squared of, this is a squared minus x squared. Okay, so here, as you will see, this is a squared, square root of a squared minus x squared, so you get x is equal to 3 sine theta. You use that. When you plug it in, then things are gonna get simpler, and this difficult integration becomes 9 integral sine squared theta d theta. You do another, you use the identity here, and then sine squared theta identity, you get it simpler. Okay, this is another example, and here's this one also. This is, on the other hand, 25 square root of 25x squared minus 4. This is the third type, which actually we would just put x is equal to a secant theta. But be careful, we have to do this rearrangement. Square root of 25x squared minus 4, you take out the 25 so that it's in the form of square root of x squared minus a squared. That's the arrangement that you do. Then you're going to substitute x is equal to 2 over 5 secant theta, and life is going to be beautiful afterwards, because everything is going to be simplified, and your integral is just integral secant theta. And you just find it by using the table, which is ln value. Now let's get back to the questions we have here. Let's see. This one, we don't have the square root, we have just 21 plus x squared and here, what could you do? We can give it a try. We don't see the square root here, but let's see whether we could do like tangent. If you remember arctangent formula we talked about, if you have, okay, recall, just a sec. Okay, so here we have a fact about arctangent, but before we do it, we just directly use the substitutions, trigonometric substitutions we have. Here we have x is equal, this looks like we can use x is equal to a tangent theta. Yeah, in this case, okay, here a is equal to actually 11, right? Because 11 squared is equal to 121. Okay, let's try it. So dx is equal to a times secant squared theta d theta, yeah? And then let's plug this in. I'm not going to write anything here. Okay, instead of dx, I'm gonna write, not a, actually, let's write 11 here. Okay, this is 11, because a is 11, we know. Okay, let's do that. Okay, this is 11, so I'm going to put it in. 11 secant squared d theta, and then how about x squared plus 121, this is equal to 11 squared tangent squared theta plus 11 squared, yeah? Take out 11 squared, you get 10 squared plus 1. 10 squared plus 1 is secant squared. Yeah, if you remember, 10 squared plus 1, sine squared over cosine squared, then you get the secant squared from there. Okay, so I go up here and I write 11 secant squared theta. They cancel, and I have d theta. Okay, the antiderivative is theta. Theta from star to star, but what's theta? Theta is equal to, if you, okay, we know that x is equal to 11 tangent theta. This implies x over 11 is tangent theta. This implies theta is equal to arctangent. Arctangent x over 11, right? So we are gonna plug in arctangent x over 11 x over 11. I'm just checking something here. This is 11 squared, by the way. 11 squared, yeah? So I have 11 left here. So 1 over 11 left here, because we have to have that. Because this is squared, they cancel, just 11 left. This is equal to 1 over 11. Maybe rewrite that nicer so that you understand. So this is equal to 1 over 11 arctangent x over 11, and x is going to change from negative 11 to positive 11. Let's go towards right a little bit to finish it off. This is going to give us 1 over 11 arctangent 1 minus arctangent negative 1. Okay, let's put this box here. Tangent has inverse between negative pi over 2 to pi over 2. So if you consider tangent's graph is like this. Negative pi over 2 to pi over 2. Okay. Tangent theta is equal to 1 when pi over 4, right? This is pi over 4. It's going to be negative 1 when it's negative pi over 4. This is negative 1. This point. Okay, here. So this is going to be pi over 4. And this is going to be negative pi over 4. And this is going to give us that. What's the answer from here? The answer is 1 over 11 pi over 2, because 2 times pi over 4 is gonna give you pi over 2. Pi over 22 is the answer. Okay, this is the final answer. Okay, let's go get back to it. So this is the question 5. Let me see. Yeah, the answer is here. Pi over 22.